Okay, so we're picking up from question 19. Pause, take a read through the question, get familiar with it, and come back. Okay, so we're looking at a dilation. Definitely graph this question. Anytime you have coordinates, you want to graph. So we're going to graph this in a second, but let's take a look at what we're looking for. We are looking for a scale factor for the dilation, and we're looking for a center for the dilation. So we know that scale factor, we always get scale factor by doing new over old. Maybe it's a new length over an old length, or it could be the distance from the center of dilation to your new point compared to the distance from your center of dilation to your old point. All right, but it's always new over old. Now, let's start with that. Go ahead and graph. I've already done that. Graph your two triangles. And now we have to make sure we know which is the new and which one is the old. So I'm going to go back to my prompt and let me see which one's the new and which one's the old. All right, so it says that the triangles are similar because triangle DEF is the image of ABC. All right, so DEF is the image, meaning DEF is the new. ABC became DEF, so this is the new. All right, I'm going to go into my diagram. I'm going to make sure I label that as my new. All right, so this is my new. Now, I have two line segments that are nice and vertical, so I can count those distances, those boxes, to figure out the length of ED and of BA. So that's going to be really simple to figure out their lengths and find the scale factor. So ED is 1, 2, 3, 4, 5 boxes. So this is a length of 5. Let me change that color. So ED is a length of 5, and then BA is a length of 1, 2.5. Remember that point B is half the way up. So it's 2.5. Okay, so if I'm figuring out my scale factor, new is the 2.5. Oh, sorry, nope. New would be from EFD, so my new distance is 5, or rather my new length is 5. And then my old length for BA is 2.5. So 5 over 2.5, K equals 2. 5 divided by 2.5, K equals 2. So my new triangle is twice as big, which that's what it looks like. So going back to my choices, for my scale factor, I'm going to be choosing choice E. Scale factor is 2. All right, so I can go ahead, I'm going to cross out D, I'm going to cross out F. Those are not the correct scale factors. Now look at my center of dilation. I have a couple of choices here. The way that we find center of dilation is we connect the image point to the pre-image point, and with a straight line, it should eventually cross where your center of dilation is. All right, so let me do 1 or 2 of them, and let's see if we can figure out where they should all cross. I'm going to connect F to C. F is the image of C. So let's see. Down 1, 2 over 1, 2, 3, 4. Down 1, 2 over 1, 2, 3, 4. I'm going to put a point right here. It's a little bit harder on this screen, but on your papers you should do it a little bit easier than I will. Okay, so that's my first line. Now I'm going to do it again for another pair of pre-image and image points. So D is the image of A. So I'm going to do the same thing. I'm going to draw a line. So I'm going from D up 1 over 1, 2, 3, up 1 over 1, 2, 3. I like to have at least 3 points where I can connect all 3. Okay, so I already know where my 2 lines are crossing. This is going to be my center of dilation. Okay, that's going to be my center, because that's where the 2 lines cross. And we know the dilations is when you're moving either away from your center of dilation or closer to your center of dilation, and that's how your image is going to form. So in this case, they're crossing at -2, +1. I'm sorry, -2, -1. So that's going to be your center of dilation. It's going to be at -2, -1. So our answer is going to be choice A. Okay, so A and E are your correct choices. Let's move on to the next question. Number 25, another similarity question. Read it through and come back. All right, when our figures are similar, which is what this little symbol tells us, That means they're two different sizes, and the way that you get from one triangle to the next is by multiplying by some scale factor. The way that we figure out our scale factor and the way that we solve for each of our missing line segments is by setting up a ratio and then setting up a proportion. So we're going to match some things up here. All right, according to the similarity statement, AB matches up with DE because they're in the first and second position. So AB and DE. All right, so that's my first set of matching sides. I'm going to do the smaller over the bigger. So I'm going to do 7 over 21. All right, and next, I'm going to match up the next pair of sides. Now, I want to find CB. So I'm going to see what that matches up with. C and B, okay, those are the second and third position. That matches up with EF because that's in the second and third position. So EF, okay, that's 5. All right, so the 5 and the X should match up. Let me finish out my proportion. 7 over 21 is my ratio, so I'm going to match that up with 5 over X. I stayed consistent. The larger triangle is my numerator. To solve a proportion, we cross multiply. 7 times X is 7X. 5 times 21 is going to be 105. And then in my calculator, I'm going to do 105 divided by 7, and I get 15. So X equals 15. And then if I notice what my scale factor is, some of you maybe have picked that up already. From 7 to 21, to get from 7 to 21, I had to multiply by 3. So to get from 5 to X, I should also be multiplying by 3. So 5 times 3 is 15. So some of you may have seen that, but other times it's not always a perfect little ratio like times 3 or times 2. So a proportion will always work. All right, let's move on to the next question. Okay, so this is a proof question. Let's take a look at this proof question. All right, we have given information. We always want to mark up the diagram. Always mark up your diagram. So angle CBD is congruent to angle BFE. Okay, now I know that those two angles are corresponding angles. They're in matching positions. But I'm going to look at what they're asking me to solve for. They're asking me to prove that angle ABF, okay, which is the vertical angle to this one up top on the right, okay, is congruent to angle BFE. Okay, so they're asking me to show that this angle and this angle are equal. All right, well, those to me, I can see the 0, Z there, so I know those two angles are alternate interior angles. But if I look at my choices, that's none of the choices. So let's see how they want us to prove it. All right, first step, they say angle CBD is congruent to BFE, given. Always going to start with a given. Next, CBD, so that same angle in the top right, is congruent to ABF. Okay, so they're talking about this pair of angles. Why are they congruent? Look at your choices. Well, to me, those are vertical angles. So, A, definition of congruent angles. No, that's not the definition of a congruent. I know they're vertical angles, and that's why they're congruent. So it's not A. B, the angles are reflexive. Reflexive means something's equal to itself. These two are two different angles. They have the same measure, but they're two different angles, so no. Symmetric, no. Symmetric means that you can flip the order of an equation. So, no, that's not going to work. Transitive, no, it's not a train of equality, and vertical angles are congruent. Ah, that's the one. Okay, vertical angles. That's exactly what I wanted. Next, they're saying that that same angle ABF, that vertical angle that we're looking at now, is congruent to BFE. Okay, now usually I would say they're alternate interior angles because I know the lines are parallel given the fact that the corresponding angles are congruent. But they didn't walk us through that proof. They didn't then show, okay, the two lines are parallel so that you can then talk about the special angle pairs. They didn't do that. They just went right to saying that those two angles are congruent. So what I know is if CBD is congruent to BFE, and then they're saying that CBD is also congruent to ABF, then because they're both equal to CBD, then those two angles should be equal to each other. It's like a train of equality. If A is equal to B, and then B is equal to C, then of course A and C should be equal to each other. So we're looking for a train of equality, which is why our answer choice is going to be D. It's the transitive property. It's talking about how if one angle equals another, and that angle equals this third angle, then they're all equal to each other. All right, so it's going to be choice D. All right, moving on to question 37. Take a read through and come back. All right, this question is a little tricky because they gave you some distractors in this question. They tell you that the length of the pipe is 12 feet. That would be if the pipe continued, it would be this length here, 12 feet. And then they told you the diameter of the pipe is 36 inches. So the diameter would be like this right here, okay? And that is going to be 36 inches. Now they're asking you in this question to find the area and perimeter of the screen. So of the square in the center here, and they did tell us that it was a square, so that's going to be very helpful for us. Okay, so let's see how we're going to figure that out. Okay, so our final answer needs to be to the nearest whole number, to the nearest whole number. Okay, now, if this is a square and they gave me one diagonal, what's special about a square and a rhombus and a kite? All of those special quadrilaterals, rhombus, square, and kite. Basically, anytime your diagonals are perpendicular, what you can do is you can use the formula diagonal 1 times diagonal 2 divided by 2. In this question, we have the length of the diagonal. It's 36 inches. The other diagonal is also going to be 36 because that's also the diameter of that circular pipe. So what I'm going to do is I'm going to multiply 36 times 36 divided by 2. 36 inches times 36 inches divided by 2. So in my calculator, 36 times 36 divided by 2. So the area is going to be 648 inches squared. That's going to be my answer for area of the screen. Now for perimeter, I need the side lengths. So this is where it gets a little bit trickier. Now, if you know about squares, you know that all of the sides are congruent, and you know that when you draw on a diagonal, you form a special type of triangle. I'm going to break out that one triangle because it's going to allow me to figure out a side length. Okay, so now we have our triangle broken out. It should be a right triangle. I know this doesn't look too right, but yes, it's a right triangle. The two sides of the right angle are going to be congruent because in a square, all of the sides are equal in length. So now all of the sides are equal and my diagonal is 36 inches. If you notice, this is an isosceles right triangle. It's a 45, 45, 90. So what I'm going to do is I'm going to use my special right triangles and I'm going to find the length of each side. So if I remember for my special rights, when the two legs are congruent, it's called x and x, and the length of the hypotenuse is x radical 2. So in order to just get x, I need to divide by the square root of 2. This was the trick that we've used in the past. I'm going to go ahead and I'm going to give myself some room to write. Okay, so to get rid of the radical 2, I'm going to multiply 36 by the square root of 2 over 2 to get rid of that radical 2 and just get x. 2 goes into 36 twice, or rather, 18 times. So it's 18 radical 2 as my x value. So if I'm trying to figure out the perimeter, all of the sides are going to be 18 radical 2. So I'm going to take 18 radical 2, I'm going to multiply it by 4, and it's going to give me an exact answer. So I'm going to do 4 times 18, that's going to be 72. So 72 radical 2 is going to be my perimeter, the exact value of the perimeter. All right, so I'm going to pause there, and we're going to look at the next video for some more problems.